All right, so we're given a piecewise function f, and we are asked to integrate that function from 1 to 5. Notice that the two functions trade off at 3, right? So the function is just a 2 until we hit 3, and then it becomes an x minus 1. So basically, we just have to integrate two pieces, right? So we're going to integrate 2 with respect to x from 1 to 3, and then we're going to integrate x minus 1 with respect to x from 3 to 5, right? So this is going to be a 2x evaluated from 1 to 3, right? Plus, this will become an x squared over 2 minus an x evaluated from 3 to 5, right? So when we plug in, we're going to get 2 times 3, which is 6, right? Minus 2 times 1, which is 2. Here we're plugging in the top bound, right? So that's going to be a 25 halves, right? Minus a 5. And then minus the bottom bound, which is going to be a 9 halves minus a 3. So there's a couple different ways to deal with this. You can clean everything up in each set of parentheses first if you want, although that would involve getting a common denominator, and that's not necessarily the most fun thing, but you certainly could. If you wanted, this is a 4, right? This is a 12.5 minus a 5, right? So it's a 7.5, right? And then this is a 4.5 minus a 3, so that's a 1.5, right? So you're going to get 4 plus 6, right, which is definitely 10. That's one way to do it. You also could have distributed some negatives. If you distributed some negatives, you could clean this up and just make the fractions disappear because it would have worked out, but this works totally fine. I chose to go the decimal route, and that's okay. However you chose to clean that up would have been okay.